Alright. BCA-101, Introduction to Computers. This is day 8. It was Friday, and we're just getting started with Unit 2. And this would have been 2, 3, 17. Alright, we covered a lot of things today. I'll try to be to the point. First thing, I didn't spend much time. There's lots of places you can look up the history of technology, at least in terms of computing devices. I first started working on computers. They were mini computers back in the 70s. And moved into PCs in the 80s. And then, of course, where we're at now. It's crazy with the internet. And so I saw the whole world of networking turn into something that was become very useful. We talked about that previously. I also did a report on Alan Turing when I was getting my computer science degree. Extremely interesting, very insightful. A lot of people said he had some of the original thoughts of how a computer could work. He designed a device to break some code during World War II. And I think it's called Imitation Games, a very good movie about Alan Turing and his life, and extremely interesting. So he would be a great resource to look at in terms of cool stuff in terms of technology. So we talked just briefly about that in class, and then we said, why do we use technology? You know, computing devices, they take those ones and zeros, you know, 8 bits and makes a byte, and they're able to take those and compare them. Basically, they can do arithmetic logic. They can do arithmetic logic unit in a PCU. It can do arithmetic, it can make logical decisions and actually move stuff around, but they really can't do anything else. So humans are way more powerful. You know, the thought process in a human is way more powerful, except a computer can do that stuff very fast. And then we measure that, like things like bits per second. Or later on you're going to learn megahertz and gigahertz, cycles per second, how many times in a second, a million, a billion cycles per second. They can do this work, and they can be extremely accurate, of course, if the software is accurate, and if we put in accurate data, they will process it and give us an accurate answer very quickly, and they don't care about how much data there is. They can manage a large amount of work, so to speak, and nowadays they're way reliable. Between the hardware, just the circuitry and so forth, just doesn't break, clear back when I used to watch TV, and they used to have tubes in the TVs before we got transistors, and they'd burn out, and even some of the early hardware PCs, the hardware itself would break, or software wasn't designed nearly as good as it is nowadays. Now we can trust them; they're reliable. So we can do things like actually let software maybe drive a car or manage landing an airplane, or all kinds of stuff, help with surgery and so forth, because of these key things. All right. So here we see the same situation when we talk about software, and we did some reviewing here in terms of software. Software has allowed us to do these things in combination with hardware. And we talked about that already previously. Software communicates to hardware, and then the hardware does its thing. And we reviewed system software and applications, operating systems and utilities. We talked about those four. And then in applications, we talked about communication software. We didn't go through everything, but we mentioned social media, we mentioned email, and there's a whole list in the outline of way we can communicate. Another one's chat, weblog or a blog, And all these have different history and how much they were used and how they were used in technology. And we should have a pretty good understanding of that. Both the plus, and there could be lots of minuses in that too. Inside the computer we have ROM, and here I talked about that arithmetic logic unit in the processor to make decisions. Okay. And somebody asked about how is a computer when you first turn it on, and we use the term we boot the computer, we first turn it on, or the first time, like if your phone is completely turned off, the first time you turn it on. Not so much for phones and tablets and so forth, but more so for any type of personal computer, like a laptop or desktop or whatever. There's software stored in there in firmware. The old term was BIOS. It's like BIOS, beginning, instructional output system. But anyway, that software is in firmware. It's actually burnt right in the chip. So when the computer starts, that software starts, and then the operating system is typically loaded off the hard drive. So you can have a PC that runs Linux, or you can have a PC that runs Windows, or some PCs are Apple machines. They run Apple OS. Okay? So here's the same diagram, and I talked a little bit about how the computer connects to a switch, that switch connects to a more sophisticated switch, and eventually this information connects out to an ISP. As much as this seems pretty simple, an internet service provider, there's a number of things we need to learn about an ISP, and we asked the students some questions a little bit in class. We discussed what do they use, what do they use for their ISP. Well, that the students are in the dorms, they're connected in right here, and they go out and they use the Iowa Communications Network for their connection to the internet, if they're using that. And we talked about that. Typically you pay for the amount coming down, and we refer to that as bandwidth, usually measured in bits per second. And I draw this signal, this symbol looks like a pipe. The bigger the pipe, the more bits per second you can have. Okay? So we talked about that connection in and out to an ISP. So ISPs typically charge in that way. Now in some cases, the communication going up and down, in and out of the internet, is one big huge pipe going both ways, like Facebook, because they got to be able to take information from their servers and send it up into the internet as fast as people coming down in to request it. Now when you're at home, and you're connected to the internet, let's see if I can squeeze you in here, to whoever your ISP is. There's some ISP, no matter what. If you're going to the internet, there's some ISP. So if you're at home, typically you'll get a large amount down and a little bit going up, because typically you're not sending much traffic up, but you're bringing a lot down, like you're downloading a file, or you're watching a video, or whatever. So you're getting a lot more coming in, and just a little bit going out, like a URL to tell it, hey, I need this, and then the website sends it down. Okay, I should mention this here, IPO. We did mention Snapchat Corporation. They just announced they're going to go public and sell stock, and initial public offering. So that'll be interesting to see how that goes. That'll happen in the next month or two. I don't know, I think Facebook offered them $3 billion for the company and they turned it down, so they must figure this is going to be way better than that. Alright. Here. Almost done here. We did introduce the beginning here. We talked about Unit 2. We're going to talk about the Internet and the World Wide Web. The World Wide Web uses the Internet to do what it does. World Wide Web is this idea of a browser, and it reads HTML, and we use Hypertext Transfer Protocol to send that around, whether it's not secured or secured. Later on we'll talk about port numbers and so forth. And then also, and then I said, well, then we talked about word processing. I'm going to go over that here in a little bit. But I did mention a couple things about the skills-based assessment. I wanted a summary. Some people gave me a chart, which was okay, comparing, like, let's say Apple and Samsung, but that you still need some wording in there to explain the chart. I understood the chart, but you should write it as if somebody who's not familiar with the project can understand it. Excuse me. And then we'll work on that during the term. A couple things between Apple and Samsung. There were a number of comments made. Somebody said that Android was a company that makes phones. Android and the iOS, that's a little I, those are operating systems and they run on phones. Android was developed by Google, and then Google gave it away for anybody to use. Well, then Samsung uses that. Apple designed their own. And by the way, some people write iPhone and iPod. The I is not capitalized, just an FYI. And then they were talking about, somebody else mentioned Apple's made in America and Samsung's made in a foreign country. Well, probably not true. I think most of the Apple phones are made at Foxconn. And we looked up Foxconn together in class. That's Foxconn. Huge company that makes, I think they make parts for Samsung too. You know, they make all kinds of technology parts. And so we tried to clarify some of that, and we will more so later on. Then word processing. Two major things we'll talk about. We'll talk about, you know, getting the text, what you want it to say, and editing that text so that the words are how you want them. Your information is there, the wording, and then you can take that information and made it easier or harder to read, so it's how it looks. That might sound funny, but you know, if you ever heard the idea of the fine print in a document or a contract, you know, that's formatting. The words are there, but maybe it's hard to read them. Or make them easier to read, like a newspaper makes columns so you can browse down the information and read it faster. And documents are designed that way. I gave the example here. When you look at a document, there's a sweet point right here, a point everybody's eyes go to, believe it or not. When you looked at the screen, you probably looked somewhere's right out in here to start with, believe it or not. And then your eyes tend to want to scan the document in what they call lazy Z. Well, I saw advertisements where they had something here like a bottle of some type of drink or whatever, and then they had the drink go here, and then they had the brand name right here. They had a bunch of text over here, but nobody reads it because their eyes go to the sweet spot, follows the liquid into the little shot glass. You read the name, and then you go on the next page in the magazine. There is a lot of things you can do. Caps makes you slow down. You know, if you have all caps, it slows up the reader. If you have any kind of text and you underline it, they claim that you read 7 times slower. Next week we'll actually mention Monday why that. So then we did some work with word processing. I opened up a document that we will use. It's some information from Seth Goggin, and then we started doing some things. I think we did some basic things. We looked at paragraph marks, and we moved a paragraph. Yeah, pretty simple. We moved a paragraph. We looked at what the page looks like. We did a little bit with margins. And I indicated, we looked at the ruler at the top of the page. All this was in Microsoft Word. We added an image, and then we wrapped text around it, and we also cropped. Okay, so we will tend to do a few of the more advanced things in class, and then answer questions on the basics in terms of word processing. And so we've got that in-class work that we'll do, and we're going to end up doing 2 different projects in class. So You'll find I'm very particular about word processing, very particular about, I'll write a couple things here, spacing, and how we line things up to get it to look good, and some basic rules about using headers and so forth, headline, and then also we'll do a number of other items. But the objectives are given in the assignment, everything we want to accomplish, and the assignment has some nice videos that get you started. As much as you think, hey, I'm an expert at word processing, I don't need to do any of that, there are some particulars you may not know how to do, or the way I want you to do them in terms of managing, setting up a document, so it's easy to read and easy for somebody else to edit and take care of. All right, that's it for today.